Formal charges are a way of keeping track of the electronic charges in molecules. They are calculated as the number of valence electrons associated with the free atom, minus the number of electrons associated with the atom in a molecule or ion. The rules for calculating the number of valence electrons in a molecule are illustrated by the example of HCl. Unshared electron pairs are assigned entirely to the atom carrying them, and shared electron pairs are assigned equally to the two atoms sharing them. The free hydrogen atom has one valence electron. The formal charge on hydrogen in HCl is calculated to be 0. The free chlorine atom has 7 valence shell electrons. The formal charge on chlorine in HCl is also calculated to be 0. Notice that the formal charge on both atoms in HCl is 0. Remember that the formal charge is not an estimate of the actual charge on the atoms. We know that in HCl, the chlorine bears a partial negative charge because it is more electronegative than hydrogen. Formal charge calculations can often help us identify the most stable isomers of molecules. Consider the isomeric compounds, hydrogen cyanide and hydrogen isocyanide. Both structures have octets of electrons about carbon and nitrogen. The formal charge on carbon in hydrogen cyanide is 0. Similarly, the formal charge on nitrogen is 0. In hydrogen isocyanide, the formal charge on carbon is -1. The formal charge on nitrogen is +1. Because the formal charges are non-zero in hydrogen isocyanide, we can predict that this isomeric form is less stable than hydrogen cyanide, as found to be the case. Formal charges can also be helpful in evaluating alternative resonance structures. Let's consider nitrogen dioxide, a molecule that contains an odd electron. We can draw two reasonable Lewis structures, but which more closely describes the nitrogen dioxide molecule? Notice that in one structure the unpaired electron is on oxygen, and in the other it's on nitrogen. In the first structure, the formal charges on all the atoms are 0. In the second structure, nitrogen bears a formal positive charge, and one of the oxygens bears a formal negative charge. Nitrogen is less electronegative than oxygen. Nevertheless, a formal positive charge on nitrogen and a formal negative charge on oxygen is an indication that this resonance structure contributes less to the ground state structure of NO2 than the previous one, with the unpaired electron on oxygen.